All right, let's get going here. Hello and welcome to our webinar here. This is, we're going to be talking a bit about the Zend PHP Cloud Application Platform. But before we actually get started, I want to cover a couple of basic things here before we get going. First of all, for most webinars, we generally have our participants on mute just because it's really hard to manage people if they're going to be talking back and forth. And so if you do have any kinds of questions, feel free to put them into the Q&A panel. If you look on your, on mine at the bottom right-hand side of the screen, there's a Q&A button that has a question mark in it. Type your question into there, and we'll get to that question as soon as we can. Most likely, I'll be ignoring that up until the end of the talk here. And at that point, we'll address any questions that you may have. I've got a fair amount of content here, but this is the first time I've done it, so I don't know exactly how it'll work out with timing, but we'll try and make sure that you have enough time at the end to be able to answer any questions that you may have. The second thing to note is that this webinar is being recorded, and so if you need to jump off for a while, or you have to leave for some reason, or if you want to share this with your friends, we will have the recording made available to you so that you can view it again at a later point in time. Because I think there's going to be a lot of interesting stuff in here that you may or may not. You may know some of it, you may not know some of it, but I think that we're going to get a bunch of interesting information here. So I think that this will be a good reference for you to start with. We'll also be following up with, I'm quite sure, blog posts and other videos and stuff like that. So there's a lot of information that you should be able to glean from this. So with that, why don't I just introduce myself a little bit. My name is Kevin Schrader. I am the technology evangelist for Zend Technologies. In the past, I've been able to work as both a programmer and a system administrator. I've worked in languages like Java. I'm drawing a bit of a blank. My first language was Perl. Obviously, I've done a lot of work in PHP. That's kind of where I spent the last several years of my life, is really being involved in PHP, mostly because of my work with Zend. I've been working with Zend now for just over 4 years, which in in Silicon Valley speak puts me pretty much to middle age already. So I've been working with Zend for a while, and I'm still here because it's a good company. We're doing a lot of good things, and I think you're going to see some of that stuff here. Just in terms of myself, I've written 2 books. The last one just got released a little while ago, about a month, actually 2 months ago. October 14th, I think, was the published date for that. That was You Want to Do What with PHP? And then the first one was IBM Programmer's Guide to PHP, which was released, I think, early 2009. And about a month ago, I released an album as well, which you can download off of iTunes, Rhapsody, Amazon, stuff like that. If you want to, you can contact me on Twitter at kpschrade. That's my Twitter handle, and I'd be more than happy to talk things through with you online, or just kind of jib-jab, that kind of stuff. Be more than happy to do that. So with that, getting my stuff out of the way, the first thing we're going to do is we're going to talk a little bit, to some degree, about what the Cloud Application Platform is. The first question that you might be coming up with is this actually a new product that Zend is going to be offering? And the answer to that is basically no. It's not a new product, but what it is a new way of thinking. It's a new way of integrating your application with cloud-based services. Cloud computing is relatively new. It's come out over the past 5 to 10 years or so. And it's really taken off over the past 3. And if you look at something like there's a thing out there called the Gartner Hype Curve. I think it's Gartner that put it out. That kind of shows where you talk about expectations. You have a height of expectations, and then as soon as you see all of your expectations were actually false, you have this significant drop off. And then after you have that drop off, you have this slow curve up to being able to utilize whatever technology it is. And I think that cloud computing now is actually on the upswing. People have stopped hyping it. Well, I shouldn't say that. People are still hyping it an awful lot, and that's kind of what we're doing here, I suppose. But what we've started to do is we've started to dispel a lot of the myths about cloud computing. People are actually starting to use cloud computing, And so what that means is that now we're actually we're going up that line of productivity and usefulness that cloud computing can actually do. But the thing about that is that it's not going to be your typical programming environment that you're used to, your typical operations environment that you're used to. I worked with a large national ISP, and we had, I don't know, several dozen people, managing the hardware and software. We had several hundred servers that we were managing. We owned our own hardware. We licensed the software, and we kind of had all this stuff in this big, massive data center that we were constantly managing, constantly fixing, and constantly having to upkeep. And that's one of the things that's really different about cloud computing, is that you don't have upkeep. If something breaks, you throw it away. What that does is, if you have some kind of an issue and your server goes down, there's some kind of a failure, rather than trying to fix it, because everything's virtual, you can pretty much just throw it away when you're done with it, or if there's something that's broken, and just restart over. This is one of the great things about using cloud computing in development, is that because it's basically a throwaway virtual environment, you can try a bunch of stuff in there, and if it breaks, who cares? Just shut down the machine, start up a new one, you're ready to go. And so when we're talking about what Xen's approach to the cloud is going to be, is it going to be some kind of a new platform? No. Is it going to be some kind of a new service offering? No. What it's going to be is an integration of all those things. It's an integration of software features, with Xen Studio, with Xen Framework, with Xen Server. It's an integration of your software with your infrastructure. So who's your cloud provider? Are you using Amazon? Are you using Azure? Are you using Rackspace? Are you using whoever? What we want to do is be able to take that software and that infrastructure and kind of merge it all together. And on top of that, a lot of cloud providers, in fact, most cloud providers, don't just simply provide hardware and software that you can run on. They actually provide a full level of APIs that you can use to build your application around. And so to utilize this new way of implementing software, to utilize this new mechanism of managing your infrastructure, to utilize this new mechanism for accessing data and scaling out data, is going to require an entirely new way of thinking for a lot of PHP developers. And so what we're trying to do is we're trying to help provide the mechanisms for doing that integration and for moving forward that new way of thinking. So we'll talk first a little bit about the value of what we have, then we're going to talk into kind of what it is. Now, one of the reasons why you would want to use the cloud application platform is, well, I've got 5 here. This is just kind of a list that I kind of just came up with off the top of my head. There are definitely more of these. Some of these may not pertain to you, but there's a couple of ones that really are interesting to me. First of all, it's standardized management. And what that means is that when you're working with a system, when we have the full platform kind of available and doing all the things we wanted to do, you're going to have things like standardized management. You're going to have integration with various third-party tooling. You're going to see a lot of this in Xen Studio, but also in Xen Server. We have a lot of partnerships that we're trying to utilize to make PHP in the cloud much more valuable. We're also, some other values that you have cross-platform compatibility for data access. Data access is always a big problem because you're almost always bound to some degree to the database that you're using, the message queue that you're using. And so people end up building a lot of abstraction to access the data, access message queues, access remote resources, all that kind of other stuff is things that a lot of people will take to themselves to manage. And what we're trying to do here is we're going to try and help you with that so that you don't have to manage the abstraction layer. We handle that. And then you just use what we provide, and hopefully it makes your life easier. Another one of the value is, I was talking primarily here about Studio and Xen Framework, but when you look at our server offering, which is Xen Server, which is basically the standard PHP stack, fully compatible with regular PHP, but with some additional functionality built into it, monitoring information on the cloud is something that's really important, because how do you know if you have a server that's being overutilized? You have to, in the traditional environment, you'd have, some kind of, server level monitoring that would be going on. Maybe you see, disk I/O is up, or maybe RAM consumption is up, and you don't really have a lot of this stuff for the insides of a PHP application. Is a MySQL function error? Is there some kind of a network connectivity issue that doesn't show up in your firewall logs? And so you have the ability to monitor this stuff currently using Zen Server Cluster Manager in your own environment. But if you're doing it in the cloud, this is much more important because you don't have control over the infrastructure, or you don't have the same level of control over the infrastructure as you would in your own environment. And so having the ability to monitor your PHP applications in the cloud is even more important because you don't have the same level of insight that you had before. And then also consistent configuration across cloud machines. When you're working in your own environment, again, you can pretty much build up a server and put some standardized templates in there, and it will run, in theory. In the cloud, it's a little bit different because unless you're building your own AMI or your own server instance or whatever it is that your cloud provider is actually handling, you now have to be able to bring up servers, configure servers, get servers ready to go, and then be able to bring them down, bring them up, bring them down, and maintain some kind of consistent configuration. And we're going to take a look a little bit about how that actually works with what we have in our offering. So consistent configuration across cloud machines is another one of the values that we have. Now, what the cloud application platform is, it's not an all-encompassing solution. First of all, it's actually a work in progress. A lot of the stuff that you'll see on here are things that we're either working on or we have future plans. There's a lot of things in here that we already have. For example, portable cloud services, native cloud services, app monitoring, cluster management, all this kind of other stuff are things that we do already, but a couple of these things, specifically app deployment, is something that we're still working on. But if you're at ZenCon and you saw Kent Mitchell's demonstration during the keynote, you see that it's something that we're actually working on. We're actually talking about a lot of stuff that allows you to auto-scale your PHP application and really bring management of your PHP application out of the realm of the system administrator, where they need to actively be watching a server to see if they need to bring up more machines. In that demonstration, we showed how the machines could simply vote and say, hey, we need more resources. And that would be something that would be managed by the system. In that case, we're using one of our partners, RightScale, to actually manage a lot of that stuff. And it was a really cool demo. But it's something that's not quite there yet. It's kind of like it was a new preview of some of the things that we're working on. And so when I'm talking about the cloud application platform, a lot of it is in place, or a lot of the features are in place, but there are other things that we're still working on. And so the building blocks here are utilizing the PHP runtime, utilizing configuration management, utilizing cluster management, app monitoring, portable cloud services, all that kind of stuff. And we're focusing on the PHP side of it because we're the PHP company. We know how to work with PHP really well. And we may know how to use Amazon, but we're not the Amazon company. We're not the Rackspace company. There are other companies out there that can do that. And so we're focusing on the PHP portion and working to bring a lot of that functionality to yourself. So we're talking about cloud management, cloud infrastructure, and the actual implementation of those services. Those are things that we're working with partners to deliver to you. And so when we look at the Zen portion of this, we have a couple of different components that kind of all are intended to work together. This is taking this previous slide here and kind of getting into a little bit more detail. So on the Zen Studio side, we have things like desktop virtualization. We actually have a presentation tomorrow with VMware that I'm going to be co-presenting with some of the VMware guys, talking about doing desktop virtualization, which, because a cloud environment is basically a virtualized environment, we have something there that is very similar in terms of what are the goals of what VMware is doing versus what Zen is doing versus what someone like RightScale is doing or Amazon. What we're all doing is we're all working with a virtualization, and virtualization gives you more efficient access to hardware, having a throwaway environment where you can just basically, if something breaks, you just build another one. So virtualization is definitely something that's important, and we are covering a lot of that in Zen Studio. Cloud server integration, cloud services tooling, those are things that are going on in Zen Studio, and I'll actually give you a little bit of a rundown of some of that in just a moment here. Under Zen Server, we have a couple of things there. You're talking about our cloud services, specifically some of the implementations that we have in Zen Framework, which I'll show you in just a moment. Simple Cloud, and also web services layer built into Zen Server. Then we have Zen Framework, which has our standard Zen Framework stuff, and it's not a framework talk, so I won't get into too much stuff there. And then you also have the runtime services. That's things like session clustering, because in a cloud environment, making sure that you have consistent data across individual requests is something that's quite important. And as you'll see in a bit, discovery of resources is something that's quite important. So trying to figure out where a session resides as opposed to just, we're going to have a database server and that's where our sessions will reside, that introduces a single point of failure. Something like session clustering allows you to work much more naturally in a cloud environment, because that cloud environment is by default intended to be fault tolerant, and a single database is not fault tolerant. So again, application monitoring, cluster management, all this other stuff in there, which is going to sit on top of the operating system, which is then managed by your cloud management and cloud infrastructure. And you see things like provisioning, auto-scaling, and the monitoring of server resources, and a bunch of other stuff. And then on the cloud services side, again, these are things that we don't provide, but we provide access to. Things like storage, message queues, data stores, or in some cases even relational database system. Both Azure and AWS, Amazon Web Services, provide some level of relational database storage for those of you who actually need it. So while some of the stuff is going to change for you, there are ways that this stuff is being integrated in a way that is, I guess you could say, cloud-worthy. So we're looking at what we're offering and what the cloud offers you. But in order to do that, there's a couple of things that you need to do in terms of your thinking if you're a PHP developer. The first one is you need to be able to think and define tasks. PHP developers are used to thinking in terms of request-response, which makes complete sense. PHP is built to run on the web very well, and it runs very well on the web. But that's doing it that way, just thinking in terms of request-response, is going to have you're going to have issues when you're talking about things like scalability or access to remote resources or discoverable remote resources. What you want to do is, if you have functionality that you want to implement on a cloud system that you really want to be able to scale out, you need to think in terms of small tasks, not in terms of web page requests. Now, you can chain tasks together and do all this kind of other stuff. That's not really what we're talking about here. What we're talking about is making sure that if you really want to scale out, that what you're not doing is simply building on a PHP script, throwing it on the cloud, and saying, hey, I'm a cloud service vendor, or something like that. You really want to think in terms of small pieces of information or small tasks that can be executed almost anywhere. Another one is loose data coupling. One of the things about the cloud, or one of the things with scalability in general, is that as soon as you introduce strong relationships between data, you reduce your ability to scale. And so what you're going to have to start getting used to are things like not doing queries for data that may not exist yet. And what that really means is that you're used to working within a relational environment, probably with MySQL, and if you're working in a scalable environment, you're not necessarily going to have that same level of expectations of your data. For example, I'm going to be showing you an example that uses a message queue using SQS in Amazon, and there's a lot of stuff that's going to appear out of order. Now, the example that I'm doing is relatively simple. It's perhaps not the perfect example, but it shows you if it actually works the way it was when I was testing it this morning. It'll show you how you need to be willing and able to handle loose data couples. Then the other one is resource discovery. The cloud itself, you can hard code a lot of your stuff into a cloud-based application, but what you want to do is you want to minimize that. So if you have a remote resource, you want to have some way of being able to discover or figure out where that resource is going to be. And actually using something like SQS, the Simple Queue system, is something that really can help you in that regard, because it's a centralized collection point, but it's a highly scalable centralized collection point where you can go and find out, okay, where's a resource that I can go, or use a load balancer. We're talking about defined tasks here, and actually one of the tasks I have that I'm going to be showing you here can technically be run through a load balancer. So you could have 5 machines on the front, just kind of servicing HTTP requests, but you could have the asynchronous parts of the application run through a load balancer and have 1,000 machines behind there and be able to scale, or I should say 1,000 virtual machines behind there, and just be able to scale all that stuff out. But you've got to be able to figure out where that all lives. And so having some level of resource discovery is something that's quite beneficial. Some things to note about the cloud. Performance is not paramount. Most likely your application will be slower. There's always this question of performance versus scalability, and I did a talk at ZenCon on the Zen Server job queue, and to some degree I think that that's inaccurate. Performance is the ability of a request to be handled quickly, and scalability is the ability of that request to be handled quickly regardless of the number of connections that come in. Now, that quickly part of it is the tricky part, because when you're dealing with a scalable solution, you need to be able to have fault tolerance, you need to be able to have multiple machines connecting in, so you have synchronization issues where you want to make sure that your data is not being accessed by multiple places at once, and so there's overhead involved in managing that. And so simply taking your application and saying, hey, we want it to go faster, let's throw it on the cloud, is probably not going to be something that's that is going to be beneficial for you. I actually know I talked with one person who they're not moving to the cloud because they basically say, we have extremely predictable traffic. Well, if you have extremely predictable traffic, then you have the ability to manage that. Most people, however, do not have extremely predictable traffic. Even with something like Thanksgiving Day and Christmas Day, or the day before Christmas, which is probably when I'm going to buy all my presents, you're going to have you're going to have spikes, but you don't know how much, and so you don't have the ability to accurately predict what level of hardware you're going to need. So you need to be able to scale, and to be able to scale that stuff, you need to be able to allow for the system to be scalable. In other words, allow for the cloud system to be scalable, and that requires that you're not going to have the same level of performance. Build your application with no hard-coded values like directory or resource locations. Either let Zen Server decide for you, or do some level of resource discovery to figure that out. But don't hard-code data into your application. Same thing with decoupling partition. I'm talking about database access and spreading machines or horizontal scalability. Consider decoupling relational data, because relational data, if you're going to scale it, you can scale relational data, but it's not necessarily. It may require an awful lot more management on the back end to make sure that's working. So take a look. Does your data need to be what's the word I'm looking for? Does it need to be relational, or can you get by with using some level of non-relational data? Use queues and messaging. I think this is actually a big one. A lot of PHP developers are used to pulling a database. A database is not intended to be some kind of temporary storage. And so I think that queuing, or using some kind of a message queue, is paramount to building a scalable system. And PHP developers are used to, okay, well, we have a database server, it's overloaded, let's add another one. Now, which is great until you have no traffic, and you have 10 servers sitting there idly, just kind of serving a little bit of traffic up. Now, what a queue allows you to do is to put data into a temporary storage that is going to make that data available as resources are available. And that's really, I think, the big part of building a scalable application, is that you need to allow for the ability to handle functionality as you have resources that are available. So that means using things like queues so that you don't have such a strong relationship to your CPU usage. Then the last one is to use stateless interfaces. One of the things that really bugged me about SQS is that I wanted to have a system that would connect to SQS and then just basically lie idle until data came in. And I was kind of reading through trying to figure out why it was that it wasn't, why Amazon didn't do that. And basically the reason is that a lazy connection or an idle connection actually consumes more resources than polling. And when you think of it, it's actually kind of true. Yes, you can get more time-sensitive data by sitting on an idle connection and waiting for data to come through. But while you're waiting on that connection to come through, if you're polling it as opposed to sitting idle, you might be able to actually handle, hundreds of times more traffic on an individual machine because you're only holding that socket open for a very minimal amount of time. And so using some kind of a stateless interface, which is what HTTP is, you have the ability to handle more requests on an individual machine. There's a lot of talk about using Comet and other types of kind of push functionality, which is fine. It's really good if you need to have immediate responses. But from the reading that I've done, I've actually found that the people who really specialize in scalability actually prefer some level of polling. It's not going to give you the same level of instantaneous data as you would have, but it does tend to be a little bit more scalable when you're doing that. So it's not as bad as it may sound. So the first thing I'm going to do here is I want to show you the example that I've kind of built. Now, what I have is in here. This is actually I'm going to be going to this in a little bit. I actually need this. I need to get my DNS name for, this is an individual AMI that I have up and running. Let's see, this one actually run. Oh, that's weird. It was running an hour ago. All right, let's try one of my other ones. We'll refresh here. All right, give me 1 second here. I wanted to show this stuff later, but let's see. That looks like Apache was down. Huh. I just love when this stuff changes on you. Don't know why that happened. Oh, I must be on the wrong machine. This must be, let me just quickly check something here. I might actually be on my cluster manager. I am on my cluster manager. I went to the wrong machine. All right, we'll take this one then. There we go. This is what I was looking for. All right, so this is an application that it basically allows you to resize images. Now, the examples that we have here are relatively small, but if you have say a video that you want to have resampled or something like that, could be something that takes a little bit of while to do, and you don't necessarily want to do that with just an inline PHP request. So what this is going to do is it's going to take this, it's going to receive the image that we're going to upload, it's going to store it on SQS so that any machine that has my my Amazon key can access it. It will then load that up in the Zen Server job queue. The Zen Server job queue will process this long-running request, and what it's going to do is it's going to send status updates using SQS, the simple queue system, and then after I upload this, then what it's going to do is it's going to be polling the SQS system to see which of the individual sizes are completed. At that point, once all of them are done, we'll be able to go and do a query against SimpleDB and see what the images are and actually be able to download an individual one. So just to show you, I'll type in my name. I'm going to specify the image that I want to resize. I'll do the cover for my book, and I want to do all the individual sizes. So I will click on Upload and hope that it works. And now you see our status is being processed. This is all stuff that's being stored via SQS. Now you see how some of this stuff kind of happened out of order. That's kind of the nature of a lot of these scalable systems, is that you're not necessarily going to be guaranteed to have a FIFO, first in, first out. And so what we saw here was how that actually worked, but I built a little bit of code to make sure that things that were handled out of order were not handled improperly. Very minimal. Took me, 3-4 lines of code just to check on that. But we see that our application, it ran in the job queue. It sent status updates to SQS as we were polling. And let me see if I can just show you my net. Yeah, so you can see the polling actually occurring here. It's going to an individual file that we'll see later on. And now that I'm done, I can click on View Processed Files, and you see all the individual files here. This is doing a simple DB query, and so I'm going to do the one that is 500 by 644, and this is now going to S3 to download the converted file. So again, it's a relatively simple thing, but it can actually be pretty complicated because this is actually a system that is designed to scale very, very high. So that's just a quick example. We'll take a look at the code that does that a little bit later on so that we can actually talk through some of the things that we've used in our example here. So the first one is Simple Cloud. Simple Cloud was a separate piece of a separate component from Zen Framework up until Zen Framework 1.11. As of Zen Framework 1.11, Simple Cloud became part of Zen Framework. And so what Simple Cloud does is it gives you access to document databases in the individual clouds that we support. I think that we support, I know I'm going to miss one. I know we support Amazon. I know we support Azure. I believe we support Rackspace and perhaps Nirvanix, I think, is the other one. I might be, actually, no, it's easy enough to check. If I go to PHP and I go to my include path and take a look. People always ask me questions about stuff in Zen Framework, and I have to always hesitate to just tell them to look at the source code, because that'll usually tell you. So we have our storage adapter. So yeah, storage, we have Azure, S3, Nirvanix, and then just a local file system. For our queue service, we have the Zen queue, which is the job queue, which I used a different mechanism for this because I have some stuff that goes on behind the scenes. But we have SQS and Windows Azure, and then for our document service, we have SimpleDB and Windows Azure built into that. So we have access to the document databases on those cloud providers. We have access to those queue services and also to the storage services. Now, on top of providing access to data and services, we also provide the ability to manage a lot of cloud-based functionality. So if you're using Amazon, you have the ability to use Zen Service Amazon EC2. That actually provides a lot of access or the ability to manage a lot of your Amazon services. So if you have to do some level of scripting or something like that to, or discovery or auto-scaling or something like that, you can do that all using Zen Framework. You also have the ability to work with Azure as well, which has a smaller feature set because it works a little bit differently from Amazon. But you can also manage a lot of that stuff using Zen Service Windows Azure in Zen Framework. So I'll let you, on your own time, to take a look at those. And there's a lot of functionality in there that would the service Amazon EC2 could, we could have a presentation on that one alone, but that's, just wanted to let you know that it's there so you can actually take a look at that. So that was, kind of our Zen Framework integration points as we have those individual services. The next one that we're going to be looking at is how Zen Studio applies to the cloud. Again, this is not necessarily a new product, a new anything. What it is we're taking our existing product line and starting to cloud enable a lot of that stuff. And so we're going to be taking a look at Zen Studio. Now, one of the things that people often talk about on an IDE is they're like, all I want is code completion on an IDE. I want it to be able to, if I type something, then I can get some code coming up and I can choose from there, which that's really not the point of an IDE. I mean, you can get really simple pieces of functionality, or really simple applications that will actually be able to handle a lot of that stuff. And if you're simply using an IDE for just doing code completion, basically you're doing it wrong. You're not really utilizing the IDE. The IDE is intended to be an amalgamation of smaller pieces of functionality that contribute to the whole. So just because you have something that does code completion or tells you where files are, that's not necessarily an IDE. There's a lot of stuff that an IDE is intended to do that you cannot, that is just well beyond just using something with code completion. So some of the cloud functionality that we have in Zen Studio is, I'll talk about it a little bit here, but integration with cloud service management. So being able to integrate with the service provider that you have. I believe that Azure actually has an Eclipse-based module that you can implement. Amazon does. And that's really one of the reasons why we specifically chose the Eclipse Foundation to work with on Zen Studio, because it's not so much what we can provide or what we can build. It's what we can provide to you based off of the size of the community out there. So you want to manage a cloud service? You can take Zen Studio and simply install the Amazon cloud service management platform. You can also integrate with cloud data handling functionality. You can integrate with your testing platform. So if you're using something like PHP Unit, we have PHP Unit support built into there, so you have that integration. You have integration with your ticketing, versioning, and bug tracking using the Myelin connectors. Integration with your debug and profiling tools, which is basically the Zen Debugger and the Zen Profiler. And then you also have strong integration with Zen Server and Zen Server Cluster Manager, which is really a big part of the whole cloud functionality, wherein you want to be able to have a lot of knowledge about what's going on inside your cloud-based application. And if you're just kind of throwing your application out there, you're not going to get that. And Zen Server and Zen Server Cluster Manager provide a lot of that. And Zen Studio provides integration with that. So what I want to do is I want to show you a real quick example of what some of that looks like. So for example, I can install the Amazon EC2 management in here, and you see that I actually have 3 machines that are up and running. And I could go in there and say, you know what, my servers, if you're not using some kind of auto-scaling, my servers really aren't all that responsive. There is a lot of load. I'm just going to go into here and I'm going to do a search. Did a search for right scale, and okay, need to launch another server. It's going to be 1. I know this 1A one is not the availability zone is a little bit low. I set up my key pair, set up my security group. I hit finish, and I have a new server running. It'll take a couple of minutes, but utilizing Eclipse, utilizing Zen Studio, you're now able to just simply manage your EC2 instances from here. And not only that, but you can also manage your database. So if I go to database development, I have a connection here to SimpleDB. So all the stuff, if I go in here, I right-click and go to Edit. Let me just move this over. You actually see a lot of the stuff that was entered in earlier on using this example here. So I take a look at this, and this is the data in SimpleDB. So I now have a direct access utilizing Zen Studio to my SimpleDB mechanism that allows me to then see the actual data that I'm working with. So actually a really kind of a cool feature. Let's see, was there anything else I wanted to show you here? I think that's probably it. We saw our database access, and we also saw our EC2 management. This is all handling directly from within Zen Studio right here. There's also a lot more functionality coming. This is something that I actually saw. It's on YouTube. It's not something that's released yet. This is a screenshot of something from YouTube. This is actually kind of a cool thing about directly connecting into Amazon. I think I may actually, I don't have that set up on this machine, but I do have the Remote System Explorer. And you'll notice here, I have the ability to connect into VMware Workstation instances. That's really what this is looking like it's going to do. I haven't actually been able to play with it yet, but we have more functionality coming in and connecting us to the cloud. And that's why I said earlier on, the cloud application platform, it's a work in progress. It's something that we're continually working for and providing new hooks for in our product line. And this is an example of something that's going to be coming up in, I don't know, I don't know exactly when, But I've seen the demo of it, and it does seem to be working, and it actually gets me pretty excited about it. So really looking forward to that. All right. Next one we're going to be talking about is Zen Server and Zen Server Cluster Manager. If you're familiar with Zen Server, then a lot of this stuff is going to be relatively, kind of a rehash of what you already know. If you're not using Zen Server, some of the basic functionality that's really interesting is the ability to handle event monitoring. If I go to my Zen Server Cluster Manager, I can take a look at my rule management, and I can do things like function errors, database errors, severe slow query execution, severe slow function requests, high memory usage. These are all things that are very difficult to manage or to measure from the outside world. So if you're using some level of server monitoring software, this stuff is difficult to see. And so what Zen Server does is gives you the ability to get insight into your application, how it's actually behaving, which is much more important in a cloud environment because, like we were talking earlier, a cloud environment is a virtualized environment, and that virtualized environment doesn't have the same level of predictability. So being able to see a lot of this stuff is don't you see an uncaught Java exception, but like a PHP, not even a PHP error. Would be a good one to see. Like a slow request execution is actually a really good one, because what happens, when you're having a slow execution request on a server that could be on opposite ends of the data center? You don't know. This allows you to see all that. And not only that, you can use things like code tracing, which I don't have it set up here, but if I go to my local host, which is on 1081. I do have several code traces here, and I just love talking about code tracing because it has saved me so much time. But I can go into here and I can see what's actually going on, and see what is actually the cause. Here we see basically this was done on my local machine, but you see in this case, this took 2100 milliseconds. Well, you know what? I might want to take a look and see why that actually happened. This is a level of monitoring that you simply just cannot get anywhere else, and so you can go through this and kind of see what happened in your production environment. And so that's really part of being in the cloud, is knowing what's actually going on, because you don't own the cloud. Technically, you don't own the virtual machines. Technically, you could probably argue you don't even know the data, though that's something that I'll let the cloud people talk about. But what this is doing here is giving you that insight that you don't get because you're running on virtualized hardware. So that's event monitoring, code tracing, session clustering, be able to bounce sessions between individual machines. If you actually do have to bring one of those cloud servers down, especially when you're talking about auto scaling, session clustering is incredibly important because you can use things like sticky sessions, but when that server gets brought down because it's being underutilized, that session needs to go somewhere. And so having session clustering built into the Zen Server Cluster Manager is really, I think, kind of a big deal. Job queue on disparate machines, and also, this I think is quite important. People are often like, well, I don't want to use Zen Server because I got to pay for it, or it's not what I'm not going to use it as much as I think that I'm not going to be using it all the time. Well, with the cloud pricing, we actually allow you to charge in the same way that Amazon charges you, and so you can actually basically it's charged based off of usage. And so you can do that, and utilizing the Zen Server AMI or even installing Zen Server on your own AMI, we do have cloud pricing availability for this. So that's something that is, again, part of the whole cloud application environment or platform, is that a lot of your cost is based off of usage, and with our cloud pricing, you're now able to implement that as well on the Zen Server side. As well. So we have the cloud pricing, we have the AMI and all that stuff available as well. So that brings us to the example. We're actually going to take a little bit of a look here, and then we'll wrap up. Let's see, I've got about 15 minutes left, so actually this works out well. In the example, we want to include easy scalability. We want to be able to scale up this application really quite quickly. We also want to include simple cloud functionality because we use a queue, we use and we use storage. We also want to use centralized monitoring so we know when something actually goes on. We want to be able to do asynchronous jobs because we don't want to have long-running requests. Long-running requests will kill your scalability. We also have Zen Studio and Zen Server integration in here. So those are the things that we're going to be looking at, and it's a pretty complex example, but let's see some code. So the way this actually worked, I'm going to go back to my PHP perspective here and close this out, and close out some of this stuff here. Where you land is on this index page. And what this index page does is it just basically takes this file, this form here, and it prints it. This is using Zen Form. Again, this isn't the Zen framework talk. So if you want to look about Zen Form, you can go to framework.zen.com and take a look at the documentation there. But what I do want to show you is how I've actually got this thing structured. I'm sure some PHP people would want to kill me for this, but I actually structured my library according to the Java naming conventions, where you start with a com for commercial org. It's basically a reverse DNS entry. And so I did org eShrade, which should technically actually be com eShrade because it's eShrade.com. But in here I have file upload, and it's basically a namespace, org eShrade forms, which extends Zen Form. This just creates the individual form that we had earlier on, and if I go back here, you'll kind of see what that looks like. This is the form that's there. That form is submitted to the index.php. You could use an MVC app. It really doesn't matter. Just kind of giving you a run through about what's all going on here. So we have our file upload, we get a response, and we validate it because we want to validate our input. Then what I do is I create a new task. This task is part of the job queue integration mechanism that I've built. It's actually relatively simple, though there's a lot of concepts that you need to get. You have the concept of a manager, which handles talking to individual job queue machines, and then you have the concept of a task, which is an individual job that's going to be run on that machine. This task, we're calling this one called org eShrade jobs process images, which basically extends this job abstract. This job abstract has two methods in there, one called run, one called execute. The method execute is called inside of your code, and what it does, it doesn't actually execute anything. What it does is it calls the manager, which will then send the job queue request to a remote machine. In this case, it's sending to the local machine, but it can be sent to a remote machine, or it can be sent to a load balancer as well, because the Zen Server job queue operates strictly over HTTP. Because it operates strictly over HTTP, all you need to do is you can throw 1,000 servers behind that load balancer, and it would automatically be able to load balance between the individual machines based off of whatever criteria you send. So all we basically do is we have this abstract class, and we have a mechanism or a method called _execute, which needs to be extended, which is where the actual functionality occurs. And in our example, we have this one called process images. You'll notice that I have, it's right down here. We overload that function, which we do a bunch of other things. First thing we do is we get our queue adapter, which is our SQS. We get our storage adapter, which is S3, and our document adapter, which is SimpleDB. Now, the way this actually works is I have a bootstrap file, and in that bootstrap file, it's actually a little bit difficult to see. There's a lot of stuff here. But I have configuration for the job queue, and I have configuration for the application. In this configuration for the application, I have my document adapter stated, my queue adapter stated, and my storage adapter stated. I have my AWS access key and secret key. And the reason I have this there is because one of the things you really want to do in a cloud-based environment where you're concerned about portability is you want to have as much as possible configurable, but not in your source code. So what this has allowed me to do is it's allowed me to actually build an application that should, in theory, I haven't tested this, but should, in theory, be able to move from Amazon to Azure with virtually no changes in there. Technically, we'd have to work around the job queue in an Azure environment, but that's actually something that'd be actually relatively simple to do. Technically, you could actually have your application running in Azure and then calling an Amazon-based job queue instance if you really wanted to do that. That's actually quite possible. So we have our configuration here. Like I said, everything is configurable. Almost none of this stuff is going to be in our source code. So what we do is we just throw it into a registry. I just did a quick and dirty as opposed to setting up a whole big massive application architecture. So I don't use static methods or don't use global type information. I just kind of threw it on here just because it gets it up and running, makes it a little bit easier. So what we do is when we're going through our task, we send a message and we send it to a queue. That queue we created up here in our constructor. We created a new queue for each individual task. And so what we do is we call queue create queue. What that's going to do is it's going to return a URL to the individual queue that was the individual data queue that was created so that we could send messages to our client. And we store that in this queue name private variable. Then when we're executing it, this is actually occurring on a completely different server. What happens is you execute it, the manager will then serialize this class, and then it'll send it off to the back-end processor where it'll be unserialized. And because this information was stored prior to it being serialized, that queue name is already going to be there. So you have a queue now on the front end web service that's being stored in the session, and the queue name on the back end, and you can use that for the two to actually communicate, the front end and the back end system. So what I do is I send a message that says processing start. Then what I basically do is I iterate through the individual resolutions that I selected that I want to have it resized for, and I basically say start at the end of that, at the start of that loop, and then after I do all my resizing, at the end of it I send another message saying that it's been complete or there's been an error or something like that, and that changes the icons on the front end page. So that's how we handle the queuing or the messaging back and forth. When we saw the progress that was actually occurring on the different image processes. So we've talked a little bit about the queuing. Now what we want to do is we want to talk about the storage. And what I did here is I actually create a file name that's going to be stored in S3 or any storage engine that's using Simple Cloud. I get the temp name, I create a temporary image, and then I call my storage adapter, tell it to store the item with the file name of that. And that basically just uploads the file and stores it in S3. Pretty much done at that point. The next thing I need to do is I need to store this information in my SimpleDB or in my document database. And so what I do is I call doc class on my document adapter, because what I don't want to do is I don't want to hard code the document class names, because the document class names are actually different for the individual document adapters. And so what this allows me to do, because they all use the same interface, I simply get the doc class, I create a new doc class, and pass all that information in, and then I give it a unique ID. And then after that, I insert the document, unlink my temp file name, and then send a message that that individual process was complete. So we have here an example that utilizes S3 to store temporary as well as final images. We have SQS, which is used to send messages to the front end from the back end server. And then we have our document database, which is used to store the sort of meta information, the file name, height, width, size, things like that. So while that's going on, we submit this to our process images. We set the name, which is my name. We set the resolutions that we want to have done, and then we upload the file and call execute. Now, what we have here in this Zen session namespace, which all these pop-ups are getting kind of messed up, we get the queue name from there. We get our own name. We get some of the sizes that we have specified in there. We store that all in the session, and we also store this response object. This response object is important because it tells us which server on the back end is going to be processing that that request, which is really important because while you can submit a job over a load balancer, what you cannot do is automatically have it load balance the same back-end server to get status. You want to see if the job's actually done. And so what I just simply have is a response class here that gives you a job number, which is a unique ID, and a server name, which tells you which server it's on, so that you can then actually go later on and check to see if that is actually completed. So that's the index file, and after that we redirect to status. Status is basically just, what is this? What did I use here? jQuery. All it does is it builds out the images on that list of all the images that were being resized, and just basically calls another file which calls status.json. This is the one that's actually checking the SQS system to see whether or not you have a message available. So what I do is I create a new session namespace here, and then what I do is I call, I get my queue adapter, and I receive all the messages that I have for it. And here I specify I can have up to 10. Oops, I should probably delete some of my debug information here. Yeah, fun stuff. So then we have, for each individual message, I get the body. If we check our process image, that body would be an example here of processing starts. We're just sending text messages back and forth. That could also be serialized objects if you wanted. So we get the body, and we just basically send that status as a JSON query. And that's how we were getting the status where we got the green check marks in there at the end, was because it was reading that data from the queue and then encoding it as a JSON string so that we could actually read it later on. Then the second last part is the list, and that's where we go. Afterwards, what we do is we do a query on our document database that was inserted in the back end. We check on the front end here. We do a query based off of the session name, which, again, I did some debug here, so I'll just remove that, which basically checks to see what the name equals a session name from images, which is, again, the storage that we have right here called images. And we get the results, and we go over each of the results, and we print each one out. You click on each one, which then goes to File. What this file is, it sets our header type, and it goes to the storage adapter and fetches the item. Obviously, there should be some more error checking in here, but what this does is it will then allow you to display the image, which is where, let's see, I have it here, yeah. So I click here on File, and what it does is it simply displays what S3 sends back to it. So if we go to Amazon now, we go to our bucket here, we can look in our public. You can see that I have all of these images now being stored here, which are then accessible to this file.php. That was a quick run-through. Some things to note. Again, the implementation details should be set via configuration. They should not be hard-coded into your application. Use getters like getDocumentClass, which we saw a little bit earlier on, because it allows you to use the vendor-specific implementation details, or document implementation. And also, don't simply rely on databases. Also think of using queues and some of the other systems out there, because that's really what they're designed for. A database is not intended to be a message queue. Rather than using the database as a message queue, use a message queue as a message queue, and your life will be better. So the question here is now, I mean, I've kind of come to the end here. I've shown you a lot of stuff. The question is, where to go from here. First of all, try out Zen Studio with some of the cloud tooling involved. There's a 30-day download, free download. You can try it out, load up some of the Amazon stuff, load up some of the Azure stuff. Just try it out. Use Simple Cloud, or try Simple Cloud with an individual cloud platform. I don't know what the Azure pricing is, but AWS has very low pricing for low usage. Something like 10 cents per gigabyte for a lot of the storage, so it's nice and cheap for you. Try out Zen Server using something like the job queue and the cluster management features. And you can also use this example app, which actually does need Zen Server. I have a link here to bit.ly/eShradeCloud, and you can download this example from there. and you should be able to run it with a working instance of Zen Server with the job queue running. You should be able to run it pretty much out of the box. You'll need to add your AWS access key and things like that, but it should work. All right, so that brings us to the end of our time. Let's see if we have any questions. So we've got, let's see, where's our Q&A? Okay, wow, we got like 15. Let's see. Okay, the first question here that I can talk to you about is when will we expect to see Zen Framework Cloud in the market? It's already there. Zen Framework 1.11 is already accessible, and it's been available for about a month, and that's where Zen Cloud is actually made available under. Paul asks, what is desktop virtualization? Desktop virtualization is something that we're not even going to be, we weren't necessarily talking about here. That's actually something we'll be talking about tomorrow during the VMware one. We're not, if we're going to be doing virtualization on the desktop, the goal of that is to give you, kind of a local instance that was that closely mimics what you can see in your production environment. Your production environment is your cloud, or you can also do your virtualization in the cloud itself for doing your development. Jeannie asks, does one have to have a Zen server on the computer in order to use Zen Studio? No, Zen Studio will work with Community PHP. Zen Server just gives you a whole bunch of really cool extras. It is a pay version, but there is actually a but a more cost-effective development solution that you can use if you want to use Zen Server on your local machine. Lee Davis asks, are there any of the Zen Cloud services going to be integrated into Zen Tool to perform quick cloud tasks such as launching and terminating an instance? My gut reaction would be to say probably not, though Zen Tool is actually built in a way where you can extend it to handle a lot of that. I don't think there would be a lot in Zen Tool that would directly pertain to building out a cloud-based infrastructure beyond perhaps maybe setting up a specific document storage container. But beyond that, probably not. You probably aren't going to want to spin up new servers from within Zen Tool. But that's not to say that you couldn't do it if you didn't want to. And plus, there's plenty of other ways of already doing it. Again, my preferred way is to either use the AWS interface or use an Eclipse mechanism. Alan Gruskoff asks, regarding message queuing, does the developer create this or use an existing PHP module for this? This is actually done inside of Zen Framework. So the question was answered. Okay, I will ignore that then. Will this integrate into Dreamweaver CS5? That's something that St. Clair Newburn was asking. Zen Framework will integrate in with Dreamweaver CS5 just simply because Zen Framework is a PHP-based framework. So you should be able to integrate that into Dreamweaver CS5. As for the other ones, that would really depend on whether or not, like AWS or Azure, that would really depend on whether or not those companies wish to integrate with CS5. So framework will. The other parts of the other components may or may not, based off of the individual company that's working with them. Source is available. Let me just go back over here. The source code is here, and so you can download that and try it out. So that was Casey Wilson was asking that. And then Lee Davis was asking, what would you suggest be the best way to manage shared objects in a cloud when auto-scaling across multiple instances? To manage shared objects in the cloud, depends on what you're trying to do. If you're trying to deal with things like synchronization and consistency issues, you're probably going to have issues. If you're going to be, if you're concerned about consistency issues, then actually it's not using something like SimpleDB would probably not be best because it will be up to 2 seconds behind, or it may be up to data may be up to 2 seconds behind, and so you have to be careful about that. If consistency is a big deal for you, then it might be worth talking about using your own document storage like MongoDB or something like that, and just running that on another cloud instance. And so that's, if you have to deal with object persistence where you need to have consistency across machines, not eventual consistency, then one of the other document storage engines will probably be more beneficial to you. Let's see, do the AMI, Raymine, I think that's how you pronounce your name, do the AMI Zen servers automatically register themselves with the cluster manager? Nope, but actually registering one is actually relatively simple. You'll notice in my cluster manager here that I have only one machine, which is 241.127. What I can do is I can go to my EC2 management, and I think this one, I'll copy the DNS name. I'll go here, add a server, put in my password, and add server. Cross my fingers. And thanks for asking that question, because I actually did want to show it actually registering it in. So now I just have to restart, and now these machines will then be in the same cluster. So that's how you would. All right, so I have a little bit of a thing I need to fix there, but that's basically how you put all these machines into the individual cluster. Man, you guys have a ton of questions. This is great. I'm going over my time, but this is great. Isa Heiskanen is asking, do I need to have a Zen server license when using the Zen server AMI? You do, and I don't have specific information on how to get one of those, but we can definitely put you in contact with one of our salespeople who will know how. But you can always use a 30-day trial license if you want to get that up and running on there. But something needs to happen on the Amazon side, which I actually didn't get around to checking out in order to get that Zen server license for the AMI. That said, if you just go to the chat on the Zen.com website and talk to one of our people there, they'll be able to put you on the right track pretty quickly. Gustavo Ramirez, Eclipse counts with the cloud tooling like Zen Studio. I'm not entirely sure what the question is. Zen Studio itself uses Eclipse, so any tooling that's available on Eclipse is automatically available on Zen Studio. So I think that's what you're asking. But that's, yeah, so Zen Studio, because it's based off of Eclipse, can automatically handle that. From Jason Semko, I'm new to all this Zen cloud computing and cloud computing in general. Is there a recommended starting source to gain knowledge in all the tasks you've completed today? Not yet. Well, there are places, but you know what? I'm going to be blogging about this over the next little while. And hey, look at that! I got some resolution issues there. But I'm going to be talking a lot more about cloud here. Most of this is stuff that's built into Zen Framework, and really getting used to the cloud is actually something that's really quite easy to do. You can basically go to AWS, go to your EC2. If you're not using Eclipse, you have to provide a credit card number, but like I said, it's dirt cheap to run. Simply go to Launch Instance. Actually, no, I'm going to show you something else too. I'm actually going to go back through Eclipse because this is something that's really cool. Is you see here this new one that we created when I just did that when I was in the EC2 AMI instances, and I just clicked on Launch. If you have PuTTY installed, this is actually kind of cool. I right-click on there, I click on Open Shell, and I'm now logged into my system. And so at this point, it's just basically a Linux VM. And so I can go in here, set up my machine. I'm using the right scale one because they've actually got some pretty solid CentOS images out there. But now basically this is a regular Linux machine. So I mean, that's pretty much all you need in order to get started. So it's actually really simple to do. All right, with that, I'm going to cut off questions just because I'm already 10 minutes over. But thank you for your time. Again, thank you for your patience in going through that last piece of code. I do realize that it was a little bit on the complex side, but the nice thing is that if you get an AMI up and running and you get Zen Server installed, it pretty much should work out of the box. I did that actually just this morning. I just set up these instances this morning, and you don't even need to use specifically a Zen Server Cluster Manager if you don't really want to, because the Zen Server job queue is available on your regular Zen Server instance. But there is information that you can go to on how to install that. I'm just doing there's a file, here we go. Go here and put this in there. So actually I'll just do that right now and show you how easy that is. By etc yum.repos.d zen.repo, paste this in, done, install yum install zen server php-5.3, and you're now installing Zen Server. This one doesn't have Cluster Manager involved, but it does have Zen Server. Okay, one last question from Yuri. Will the presentation be available on the internet? Yes, we are recording this. The recording will be made available. Check our Zen Technologies web page, Facebook page, and I will post that when that's available, and I'll also have the slides up on SlideShare at some point too. All right. With that, thank you very much for your time. Again, I apologize for going over a little bit here, but I hope that what you got here is interesting. And even if you didn't walk away from here going, hey, I know how to do everything, maybe you walked away from here knowing how to do enough to get you going. And so that's really what my hope is. So again, follow us on Facebook. You can follow me on Twitter. Email me at kevin@zen.com if you have any questions. I would love to hear from you with that. Thank you, and have yourselves a good day.